Okay, for this one now, kind of the same concept as the last one. We need to eliminate one variable right off the bat. But if you look, it's not nice and easy to kind of pair any one or two variables up. So, like I said in your notes, I said I think y would be the easiest one to eliminate, but we already eliminated that last problem. So I'm going to choose x instead. So let's pair it up. And in this case, I'm going to pair the first two and then the first and last. Why? Because with this x being a coefficient of 1, it's going to be a lot easier to multiply that problem by the other ones. Or then trying to figure out, and then trying to have to multiply both to have them cancel out. So let's pair those two up. So it's going to be x plus 4y minus 5z equals negative 7. 3x plus 2y plus 3z equals positive 7. And then x plus 4y minus 5z equals negative 7. And 2x plus y plus 5z equals 8. So some of you might look and say, well, we can cancel our z's here. You're right, we can, but we can't cancel them here. So it'd be stupid to cancel that out. So let's cancel what we set out to do, which was our x. Now, as the form that it's in, it can't cancel. We have to multiply. We have to make this equal negative 3. So how do I do that? What do I have to multiply 1 by to make it negative 3? Well, negative 3. But to be mathematically correct, we have to multiply everything by negative 3. So this is actually going to change to negative, it will be negative 3x minus 12y plus 15z equals a positive 21. Because that's how all of those terms multiplied by negative 3. Well, then the same thing here. I want to cancel out our x's. So what do I need to multiply this first equation by? Negative 2. So doing that, negative 2x minus 8y plus 10z equals positive 14. Okay, then from there, we can eliminate, just like we did in the previous lessons. So that will cancel. This will go to negative 10y plus 18z equals 28. And then here, this will eliminate and we'll have negative 7y plus 15z equals 22. Okay, so now again, just like the last example we did, we write our system. Okay, so here's our new system of just two variables. So now we need to solve that. But once again, nothing cancels here. So what does that mean? We just stop, we're done, we give up? No, we go back to our elimination method or our lesson 1 and lesson 2 and figure out how to solve this. Could you solve it by graphing? Yeah, technically you could. Solve for y and go from there. Will it be the easiest method? Probably not. Could you solve by substitution? Yes. But since neither of my coefficients are 1, I'm not going to do that. So I'm going to, again, solve by elimination. And I know 10 and 70 share a multiple, but for some reason in your notes I did not choose to cancel that out. I guess I chose to cancel your z out. So 18 and 15 share a common multiple of 90. And right now they're both positive, so we're going to have to make one negative. So 18 times, negative 5. If I multiply this first by negative 5, this will go to negative 90z. And if I multiply this by positive 6, it will go to positive 90z. Now, is this the only way you could solve it? No. Like, I could try to cancel out my y's, and I could multiply that by negative 7, and then this by positive 10. or sorry, yeah, by positive 10, and then I'd have a positive 70y and a negative 70y, they cancel out. So there's a lot of different ways you could do it. Is this the best one? Maybe, maybe not. So let's multiply that out. So I'll have 50y minus 90z equals negative 140, and then I'll have negative 42y plus 90z equals 132. Okay, and then we can add, because if you notice my z's will eliminate. And let's get rid of them. 50y minus 42, or 50 plus a negative 42 is 8y. That cancels, and we're left with negative 8. So we get y equals negative 1. Great, I have one solution. So now we use that, plug it into our two variable systems, and solve for the other variable there, which is z. I think in your notes I plug it in the first one. So we do negative 10 times negative 1 is 10. So we have 10 plus 18z equals 28. Subtract our 10, we have 18z equals 18, z equals 1. Okay, great. Now I have two of the variables, I need the third. So let's find what x is. And to do that, we have to plug both of those into one of my original systems. So I use the first one. So x is still unknown, and it's going to be x minus 4, because 4 times negative 1 is negative 4. And then it's going to be minus 5, because 5 times positive 1 is negative 5, and that's going to equal negative 7. So simplify this, I have x minus 9 equals negative 7. Add 9, and I get x is positive 2. So there's my solution. 2, 1, negative 1. And by all means, plug it in and check to make sure it's right. So I'd have 2 plus 4 is 6. Oh, I wrote that wrong, sorry. It's 2. Y is negative 1 and z is positive 1. If I would have seen those there, I would have realized that. Okay, so anyway, 2 plus negative 4, so that's negative 2, and negative 2 minus 5 is negative 7. That first one checks. 3 times 2 is 6, 6 plus a negative 2 is 4, 4 plus 3 is 7, that checks as well. 2 times 2 is 4, 4 plus negative 1 is 3, 3 plus 5 is 8, so that checks. So that is that solution is the solution to that system.